Welcome to Lesson 4.9 of the Grant Architect course, where we move from the conceptual elements of logic models to the practical aspects of creating professional visual presentations. In this lesson, we explore visual design tools for creating professional logic models that communicate your program theory clearly and persuasively to reviewers. A well-designed logic model communicates your program theory clearly and makes complex ideas accessible to busy reviewers who may spend only minutes evaluating your proposal. Poor visual design can obscure even excellent program thinking, while excellent design makes complex ideas immediately understandable and memorable. By the end of this lesson, you will understand software options for creating logic models, design principles that enhance clarity and professionalism, and formatting strategies that meet specific funder requirements while maximizing visual impact. Visual design matters significantly for logic models and should not be treated as an afterthought. First impressions are formed quickly, often in seconds. When reviewers see a well-designed logic model with clean lines, consistent formatting, and clear organization, they form positive expectations about the entire proposal and the organization behind it. Poor design creates negative first impressions that are difficult to overcome even if the program content is excellent. Clarity is enhanced substantially by good design decisions. Logic models present complex relationships between multiple elements. Effective visual design makes these relationships clear and understandable at a glance. Poor design obscures even sound program theory and forces reviewers to work harder to understand your program. Professionalism is demonstrated through polished visuals in your proposal. Organizations that produce professional documents signal capacity to implement professional programs. Visual quality correlates with perceived organizational competence in reviewers' minds. If your materials look sloppy, reviewers may wonder if your program implementation will also be sloppy. Communication effectiveness improves dramatically with good design. Reviewers typically have many proposals to read in limited time. Effective design reduces their cognitive load, making it easier and faster to understand your program. Easier comprehension leads to better scores and more favorable reviews. Microsoft PowerPoint is a common choice for logic model creation that most organizations already have access to. Accessibility is a major advantage of using PowerPoint for logic models. Most organizations already have PowerPoint as part of Microsoft Office suites. No additional software purchase or approval process is required. Budget-constrained organizations particularly appreciate using existing resources rather than purchasing new tools. Familiarity means staff usually know how to use PowerPoint already from other work. Learning curves are minimal because people can create logic models using skills they already possess from presentations and other documents. New staff can update logic models without specialized training. Templates are widely available online and from funders themselves. Many organizations and websites offer PowerPoint logic model templates you can download and customize. Starting with a template accelerates development significantly and ensures you include all required components. Some funders provide their own preferred templates that you should use. Limitations exist because PowerPoint was not designed specifically for complex diagrams with many connecting elements. Creating sophisticated visuals requires workarounds and may be time-consuming. Precise alignment and connection lines can be challenging to achieve. For simple logic models with straightforward linear flow, PowerPoint works well. For complex models with multiple pathways and many elements, dedicated diagramming tools may serve you better. Microsoft Word with SmartArt offers another accessible option that integrates directly with your proposal document. Integration allows creating the logic model within your proposal document itself without managing separate files. No separate graphic file to manage, convert, or insert. The logic model stays directly connected to your narrative and updates together. This simplifies version control when making revisions to both the logic model and narrative simultaneously. SmartArt provides built-in diagram tools for creating basic visuals without learning new software. Process diagrams, hierarchy charts, cycle graphics, and relationship visuals can represent logic model components effectively. SmartArt automates some formatting decisions and makes creating professional-looking diagrams relatively simple for people without graphic design skills. Simplicity makes Word appropriate for straightforward logic models with clear linear flow. If your logic model is relatively simple with few components and direct connections, Word SmartArt may be sufficient for your needs. Quick creation without learning new software allows fast turnaround when deadlines are tight. Limitations include less flexibility than dedicated diagram tools offer. Complex logic models with many elements, multiple causal pathways, detailed annotations, or unusual layouts may exceed Word SmartArt capabilities. Consider your specific complexity needs when choosing tools. Lucidchart and similar online tools offer powerful diagramming capabilities that many grant teams find valuable. Cloud-based access means you can work from anywhere without software installation on specific computers. Log in from any computer, tablet, or even phone and continue working on your logic model. Updates save automatically to the cloud so you never lose work. Collaboration features allow multiple users to work on the same logic model simultaneously in real time. Grant teams can develop logic models together even when working remotely. Team members can add comments and suggestions directly in the document, streamlining the review and revision process. This is particularly valuable for distributed teams or when working with partners in other locations. Templates include extensive logic model libraries maintained by the platform. Professional templates provide starting points for various logic model formats, including simple linear models and complex multi-pathway designs. Customize templates to match your specific program structure and funder requirements. Export options support multiple formats needed for proposal submission. Save your logic model as a high-resolution image for insertion into Word or PDF proposals. Export as a standalone PDF for appendices or embed directly in online grant application systems. Flexible output options help you meet various funder requirements without recreating your logic model in different formats. Specialized software tools focus specifically on logic model creation. TOCO, which stands for Theory of Change Online, provides a platform designed specifically for theory of change development. It guides users through the process and produces professional outputs. DoView offers visual strategic planning software with logic model capabilities. It supports complex program designs with multiple pathways and detailed outcome chains. Logic Model Builder from the Centers for Disease Control and Prevention provides a free tool specifically for logic model development. Government-sponsored and freely available, it walks users through logic model creation step by step. The advantage of specialized tools is that they are built specifically for program planning. Unlike general diagramming tools, they understand logic model conventions and guide appropriate construction. Canva and similar design platforms offer strong visual capabilities. Visual appeal is a strength. These platforms produce attractive graphics that look professionally designed. Modern aesthetics enhance logic model presentation. Templates include modern professional options. Logic model and diagram templates provide starting points. Extensive customization makes them adaptable to various needs. Ease of use makes these platforms accessible to non-designers. Intuitive drag-and-drop interfaces require no design expertise. Achieve professional results without professional skills. Branding integration makes it easy to apply organizational colors and logos. Consistent visual identity across proposal documents strengthens organizational presentation. Design principles guide effective logic model creation regardless of which tool you choose. Simplicity means including only essential elements in your logic model. Logic models should communicate clearly, not comprehensively demonstrate everything you know. Include what reviewers need to understand your program theory. Omit unnecessary details that clutter the visual and distract from your core message. When in doubt, leave it out. Hierarchy ensures the most important elements stand out visually. Visual emphasis should match conceptual importance in your program. Outcomes typically deserve more prominence than inputs. Use size, color, boldness, or position to create hierarchy that guides reviewers' attention to what matters most. Alignment requires that elements line up precisely both horizontally and vertically. Sloppy alignment looks unprofessional and can actually confuse relationships between elements. Use grid lines and alignment tools in your software to ensure precision. Even small misalignments are noticeable to reviewers and suggest carelessness. Consistency means using consistent formatting throughout your logic model. If inputs are in blue boxes with rounded corners, all inputs should be in identical blue boxes with rounded corners. Font sizes, colors, shapes, and line styles should follow consistent rules that reviewers can learn and follow. Color and typography significantly affect logic model readability and visual appeal. Color coding uses color to distinguish different types of components systematically. Inputs in one color, activities in another, outputs in a third, and outcomes in a fourth. Color creates instant visual organization and aids navigation through complex diagrams. However, avoid using too many colors, which creates visual confusion. Limit yourself to 4 or 5 distinct colors maximum and use them consistently. Contrast ensures text is readable against background colors in all viewing conditions. Dark text on light backgrounds or vice versa works best. Low contrast makes text difficult or impossible to read, especially when printed or viewed on projectors. Test readability carefully before finalizing, especially for any text that will be printed in black and white or viewed by people with color vision differences. Font choice should select professional, readable fonts appropriate for diagrams. Sans serif fonts like Arial, Calibri, or Helvetica work well for diagrams because they remain legible at smaller sizes. Avoid decorative fonts that reduce readability or look unprofessional. Use consistent fonts throughout rather than mixing multiple typefaces. Size hierarchy uses text size intentionally to indicate importance and create visual organization. Larger text draws attention first. Component category labels might be larger than detailed descriptions within boxes. Make size differences intentional and consistent throughout your diagram. Flow and connection elements guide reader understanding of relationships between logic model components. Direction establishes clear flow that readers can follow intuitively. Most logic models flow left to right or top to bottom following natural reading patterns. Readers should understand immediately how to read the diagram without instructions. Consistent direction throughout prevents confusion and makes your logic immediately clear. Arrows show relationships and sequence between elements visually. Arrow direction indicates flow from one element causing or leading to another element. Arrow style might indicate different relationship types, such as direct causation versus contribution. Use arrows intentionally to convey meaning rather than just decoration. Ensure arrows actually connect the boxes they should connect without ambiguity. Spacing allows adequate room between elements for visual clarity and readability. Crowded logic models with elements packed tightly together are difficult to read and look unprofessional. White space improves comprehension by giving the eye places to rest. If content does not fit comfortably, simplify rather than squeeze more into the same space. Grouping visually clusters related elements together to reinforce their connection. Components belonging to the same category should appear near each other. Visual grouping reinforces conceptual relationships and helps readers understand program structure. Use boxes, background colors, or visual boundaries to show groupings clearly. Meeting funder requirements ensures your logic model is accepted and effective. Format specifications define required file types and dimensions. Some funders specify PDF, others accept Word. Size limits may apply. Check requirements before finalizing design. Page limits may include logic models. If your logic model counts toward page limits, design accordingly. A full-page graphic uses a page of narrative space. Consider whether appendix placement is allowed. Accessibility ensures readability for all reviewers. Some reviewers may have visual impairments. Ensure adequate contrast, readable font sizes, and consider providing text descriptions. Submission method determines how to include the visual. Online systems may require specific file types. Some allow embedded images, others require attachments. Test upload before deadline. Common visual mistakes undermine otherwise excellent logic models and should be avoided. Overcrowding puts too much information into limited space. When everything is included with equal emphasis, nothing stands out and nothing is truly clear. Prioritize essential information ruthlessly. Simplify content rather than squeeze more into the same space. If your logic model requires a magnifying glass to read, it has too much content. Inconsistency occurs when formatting varies without clear reason. If box sizes, colors, fonts, or line styles change randomly throughout the visual, it appears careless and unprofessional. Unintentional variation confuses readers and makes them question your attention to detail. All variation should be intentional and meaningful. Poor quality results in blurry, pixelated, or distorted images that look unprofessional. Low-resolution graphics look especially bad when printed or when reviewers zoom in to read small text. Ensure adequate resolution for print, typically 300 dots per inch or higher. Test print quality before submission and adjust if needed. Misalignment means elements are not properly aligned with each other. Boxes should line up horizontally and vertically where appropriate. Text should be centered or aligned consistently within boxes. Use alignment tools in your software rather than trying to align by eye, which is rarely accurate. Iterating your design improves the final product. Draft early by creating rough versions first. Do not wait until the deadline to start visual development. Early drafts allow time for improvement. Perfection is not expected initially. Get feedback by sharing drafts for input. Others will see problems you miss. Fresh eyes catch confusion and errors. Seek diverse perspectives, including non-experts. Test comprehension by checking whether others can understand it. Ask someone unfamiliar with your program to explain the logic model. If they cannot, the design needs improvement. Refine progressively by improving through multiple iterations. Each draft should be better than the last. Allow time for multiple revision cycles. Final versions reflect cumulative improvement. Here is a practical exercise to apply what you have learned. Step 1. Select a tool appropriate for your skills and needs. Consider your software access, design skills, and logic model complexity. Choose a tool you can use effectively. Step 2. Find or create a template matching your logic model format. Search for existing templates or create a basic structure. Starting with a template accelerates development. Step 3. Draft your logic model with placeholder content. Put your logic model components into the visual format. Focus on structure before perfecting content. Step 4. Apply design principles and refine visual presentation. Review for simplicity, hierarchy, alignment, and consistency. Improve colors, fonts, and spacing. Iterate until the design communicates clearly. Let us summarize the key points from this lesson. Tool options range from familiar software like PowerPoint and Word to specialized platforms like Lucidchart and theory of change tools. Choose based on your needs, skills, and complexity requirements. Design principles guide effective logic model creation. Simplicity focuses on essentials. Hierarchy emphasizes importance. Alignment ensures precision. Consistency applies rules throughout. Funder requirements must be met. Check format specifications, page limits, accessibility needs, and submission methods before finalizing your design. In our next lesson, we will explore narrative alignment, focusing on connecting your logic model to the proposal narrative. The logic model and narrative should tell the same story in different formats.